Carboxylic acid. These are hydrocarbon derivatives containing the carboxyl group. So you've got a C with a double bonded O and an OH group attached. So basically a carbonyl and a hydroxyl on the same carbon, and it's part of some carbon chain. These are weak organic acids, and you will always find this functional group on an end carbon. So we won't need numbers for the functional group, just like as in aldehydes. So naming, find the longest carbon chain. This is the root, you take off the E. So propane, take off the E, and you add oic acid, so propanoic acid. Identify the prefixes by identifying side groups and location from the carbon 1. So for instance, we have 3 carbons. This has 3 carbons, so the root is propane. So you take off the E and add oic acid. So this is propanoic acid. There's no other side groups, so we don't have to add anything else. Just propanoic acid. All right, let's take a look at these structures. So first one on the left here, we have 2 carbons in our longest carbon chain. So that is going to be called ethanoic acid. Ethane for 2 carbons, oic acid. So ethanoic acid. All right, the next structure, our longest continuous carbon chain is 4, but we will have a side group. So 4 means butan, so it's butanoic acid. That takes care of those 4 carbons, and then we have a methyl group, and that methyl group is on carbon number 3, because you start counting from the functional group. So this is 3-methyl butanoic acid. So when you are drawing your carboxylic acid, identify the root, identify the longest carbon chain, put out your carbons, add the carboxyl group on the end, and then number from that position for your side groups. So if we had propanoic acid, we see that prop means 3 carbons. Put in your functional group, and then place your hydrogens because there's no side groups. So there's propanoic acid. All right, 4-methyl pentanoic acid. So our longest carbon chain is 5 from pentanoic. Put in your functional group, and then go back and put in your bonds and any side groups. So the carboxyl group is on carbon number 1, so we want carbon number 4 to put on our methyl group. And now go in and put in all your hydrogens. So there's the structural formula for 4-methyl pentanoic acid. Physical properties. So the carboxyl group is very polar. You've got a dipole there, and you've got dipoles here. So you have a net dipole. So all 3 intermolecular forces are present. London dispersion and dipole because it's polar, and hydrogen bonding because of this OH group. Boiling points are higher than any other groups because they will make hydrogen bonds at the OH, but you can also accept them here at the carbonyl group. All are liquids at room temperature. Now they are soluble in water because they can hydrogen bond in two different places. This one can form hydrogen bonds with water and accept hydrogen bonds, and this can also accept hydrogen bonds. But the longer the carbon chain, the bigger your R group, the less soluble they become.